The F-16 Fighting Falcon is a single-engine, multi-role fighter jet. It was originally developed by General Dynamics, now part of Lockheed Martin, for the U.S. Air Force as part of the Lightweight Fighter Program. The YF-16 prototype first flew on February 2, 1974, and the aircraft officially entered service in 1978. This jet is renowned for its innovative fly-by-wire control system and exceptional maneuverability, allowing it to pull up to 9 Gs. The F-16 is incredibly versatile, excelling in dogfights, precision ground strikes, suppression of enemy air defenses, and reconnaissance missions. It evolved from a lightweight day fighter into an advanced all-weather combat platform. Since 1976, over 4,600 units have been built across various modifications, making it one of the most widely used fighters globally. As of 2024, it serves in the air forces of more than 25 countries, and production of modern versions, like the Block 70 and Block 72, continues strongly today. The fighter was created through a multinational consortium involving the United States and 4 European NATO allies: Belgium, Denmark, the Netherlands, and Norway, with Portugal joining later. The primary focus was on keeping it cost-effective and compact, while leveraging technology from predecessors like the F-15 Eagle. To strengthen cooperation within the alliance, final assembly lines were also established in Europe. The single-seat F-16A variant made its first flight in December 1976, followed by the two-seat F-16B in 1977. By October 1980, they achieved initial operational capability with the U.S. Air Force. The aircraft quickly proved its combat effectiveness during operations like Desert Storm in 1991, where an F-16 scored the first American air-to-air victory of that conflict. Subsequent modifications, including the F-16C and F-16D, introduced in 1984, featured improved radar and avionics, significantly expanding their multi-role capabilities. These fighters were equipped with the APG-68 radar, AMRAAM missiles, and Lantern targeting pods for night and all-weather missions. The technical specifications highlight the robust design of the F-16. It has a length of 49.3 feet and a wingspan of 32.8 feet. Its top speed exceeds Mach 2, and it has an operational ceiling of 50,000 feet. Armament includes a 20mm M61A1 Vulcan cannon, along with the ability to carry up to 17,000 pounds of air-to-air and air-to-ground ordnance. The aircraft is powered by high-performance engines like the Pratt & Whitney F100 or the General Electric F110. Later versions, such as the Block 50 and Block 52, offer increased thrust and an extended structural lifespan of up to 12,000 flight hours. This will allow them to remain in service without major overhauls until 2060 and possibly beyond. Modern upgrades, such as the APG-83 radar, the automatic ground collision avoidance system, which has saved the lives of many pilots since 2014, and the integration of advanced targeting pods like Sniper, ensure the F-16 will remain a cornerstone of air forces worldwide. The United States continues to modernize its fleet, focusing on electronic warfare and missile defense. As of 2021, the U.S. inventory included over 1,000 F-16C and F-16D jets. Their maintenance is supported by a global supply chain that creates tens of thousands of jobs and generates billions of dollars in economic impact. In the early 1970s, the United States Air Force recognized a need to address gaps in its tactical air capabilities following the Vietnam War. It became clear that a highly agile and cost-effective fighter was required to complement heavier aircraft such as the F-15 Eagle. The Lightweight Fighter program officially kicked off in January 1972 at Wright-Patterson Air Force Base in Ohio. The objective was to develop a lightweight, single-engine day fighter emphasizing high maneuverability, low operating costs, and simplicity. Initially, this was intended purely as a technology demonstrator, not for mass production. Key requirements included a maximum takeoff weight under 20,000 pounds and the implementation of advanced fly-by-wire controls to enhance agility. It also needed to be affordable, allowing the Air Force to procure a significant number of aircraft compared to more expensive alternatives. General Dynamics, along with Northrop, was selected to develop prototypes. They began work on the YF-16 in response to the 1972 request. This design incorporated innovative features like a relaxed, static stability airframe and digital fly-by-wire controls, providing the aircraft with exceptional handling characteristics. The first YF-16 prototype rolled out at their Fort Worth facility on December 13, 1973, and was then transported to Edwards Air Force Base for testing. Following an unintentional brief flight on January 20, 1974, the official first flight occurred on February 2, 1974. Test pilot Phil Ostreicher piloted the aircraft, showcasing its remarkable responsiveness and far exceeding all expectations. The second prototype followed on May 9, 1974. Early flight tests demonstrated that the YF-16 possessed significantly superior maneuverability compared to the competing Northrop YF-17. It achieved tighter turn radii, boasted a higher thrust-to-weight ratio owing to its single Pratt & Whitney F-100 engine, and featured a simpler design that promised lower maintenance costs. The prototypes underwent rigorous testing, including a direct fly-off against the YF-17 at Edwards Air Force Base from late 1974 into early 1975. The YF-16 proved dominant in simulated air-to-air combat scenarios, largely due to its agility and pilot-friendly controls. On January 13, 1975, Secretary of the Air Force John Luther McLucas announced the YF-16 as the winner of the competition. This decision paved the way for full-scale development under the new Air Combat Fighter program. Following the successful prototype testing in 1974, the Air Force expanded the project in 1975. It evolved into the Air Combat Fighter Initiative, with the aim of creating a multi-role aircraft capable of performing both air superiority and ground attack missions, working in conjunction with the heavier F-15 Eagle. Winning the competition against the YF-17 resulted in General Dynamics securing a $417.9 million contract for the full development of the F-16. To foster international collaboration, the United States signed an agreement on June 10, 1975, with Belgium, Denmark, the Netherlands, and Norway. This multinational fighter program enabled F-16s to be manufactured in Europe. It included a commitment for 998 aircraft, 650 for the United States Air Force, and 348 for the European partners. In 1976, General Dynamics received the initial contract to build the F-16A. Initial low-rate production commenced in 1977, and the very first aircraft was delivered to the Air Force in 1978. The production of the F-16 Fighting Falcon began following the initial contract awarded to General Dynamics in 1975 after winning the Air Combat Fighter competition. The first operational F-16A was delivered to the United States Air Force in January 1979. This marked the start of deliveries, following the prototype's first flight in 1974. Production ramped up significantly during the 1980s, reaching peak rates with hundreds of aircraft assembled annually to meet both domestic and international demand. By June 2024, a total of 4,599 F-16s had been produced, with ongoing manufacturing ensuring the program will surpass 4,600 units by the end of the year. Primary manufacturing occurred at the General Dynamics and later Lockheed Martin facility in Fort Worth, Texas. This served as the main production site from the program's inception through 2017. In 2017, Lockheed Martin announced the relocation of the F-16 production line to its Greenville, South Carolina site to consolidate operations and support foreign military sales. The Greenville facility commenced production in 2019, with the first Block 70 and Block 72 aircraft rolling off the line and achieving their maiden flight in January 2023. This shift marked the end of assembly in Fort Worth after over 4 decades, while Greenville now handles complete production and modifications. European co-production was integral from the outset, involving Belgium, Denmark, the Netherlands, and Norway as part of the European Participating Air Forces program launched in 1977. Assembly lines were established at Fokker in the Netherlands and Sabca in Belgium, where components like wings were manufactured and integrated into the first United States Air Force aircraft as early as July 1978. These facilities co-produced 348 aircraft for European nations and contributed to the initial 650 United States units, sharing work across the consortium to foster industrial collaboration. Export production has been a cornerstone of the F-16 program, with over 2,000 units delivered to more than 25 countries since 1975, accounting for the majority of total output. Licensed assembly occurred in Turkey under a 1980s agreement where Turkish Aerospace Industries built 232 Block 30, 40, and 50 aircraft for the Turkish Air Force, using United States and European parts. Similarly, Korea Aerospace Industries in South Korea conducted licensed production of KF-16 variants starting in the 1990s, assembling Block 30 and Block 52 models for the Republic of Korea Air Force. These efforts not only met local needs, but also built indigenous capabilities, with total exports exceeding domestic United States production figures. The Common Configuration Implementation Program, or CCIP, initiated in the late 1990s and fully implemented by the early 2000s, represented a major $1 billion effort by the United States Air Force to standardize and upgrade avionics across approximately 650 Block 40, 42, 50, and 52 F-16s. This program enhanced mission capabilities through improved radar processing, multifunction displays, and the integration of advanced targeting pods, ensuring interoperability and extending operational effectiveness without requiring full airframe replacements. In the 1990s, the Block 50 and 52 upgrade variants introduced significant enhancements, including more powerful engines like the General Electric F-110 GE-129 or Pratt & Whitney F-100P W229. These engines provided increased thrust and reliability for multi-role operations. These blocks also featured upgraded radars with extended range and precision targeting for air-to-surface missions, particularly tailored for suppression of enemy air defenses, or SEAD roles, in the Wild Weasel configuration. This enabled the integration of high-speed anti-radiation missiles, known as HARM, to counter radar threats effectively. Recent Wild Weasel upgrades, part of ongoing SEAD modernization, have further incorporated advanced electronic warfare systems and sensor fusion to maintain relevance in contested environments. The Service Life Extension Program, launched in the 2000s and accelerated in the 2010s, has been pivotal in prolonging the F-16's airframe durability. It increases the certified flight hours from 8,000 to 12,000 per aircraft, potentially extending service until 2048 or beyond for up to 300 Block 40 to 52 models. This structural reinforcement, conducted at facilities like the Ogden Air Logistics Complex, includes wing and fuselage modifications to handle higher stress loads while integrating modern avionics. Complementing this, the Post-Block Integration Team program, valued at $6.3 billion and covering 608 aircraft, delivers comprehensive upgrades such as active electronically scanned array radars and enhanced communications, representing the largest combined modernization effort in the F-16's history. Internationally, upgrade packages have tailored the F-16 to specific operator needs. A prime example is Taiwan's Peace Phoenix Rising program, a $4.5 billion initiative completed in 2023. This modernized 139 legacy F-16A and B aircraft to the F-16V Block 70 to 72 standard. This upgrade integrated Northrop Grumman AN/APG-83 active electronically scanned array radars, advanced mission computers, and electronic warfare suites. This significantly boosted air superiority and survivability capabilities for the Republic of China Air Force. Similar programs in other nations, such as those enhancing suppression of enemy air defenses roles, underscore the F-16's adaptability through customized avionics and weapons integrations. The F-16 Fighting Falcon features a blended wing body design. This seamlessly integrates the wings with the fuselage to enhance aerodynamic efficiency and internal volume for fuel storage, while incorporating area ruling to minimize transonic drag. This configuration includes forward, canard-like strakes on the nose section to improve pitch control and high angle of attack performance, contributing to the aircraft's overall agility. Additionally, the airframe employs a frameless bubble canopy that provides the pilot with 360-degree visibility, optimizing situational awareness during combat maneuvers. The airframe measures approximately 49 feet 5 inches in length and has a wingspan of 32 feet 8 inches, with a height of 16 feet. This creates a compact design that balances maneuverability with payload capacity. Construction primarily utilizes aviation-grade aluminum alloys, comprising about 80% of the structure for its strength-to-weight ratio. This is supplemented by 8% steel, 3% composites for weight reduction in non-critical areas, and 1.5% titanium for high-stress components. This semi-monocoque stressed skin approach ensures durability while keeping the empty weight around 19,700 pounds. The F-16 incorporates a relaxed static stability concept. The aircraft is intentionally designed to be aerodynamically unstable to enable superior agility, with structural limits allowing sustained maneuvers up to 9 Gs, even with full internal fuel. This is seamlessly supported by integration with fly-by-wire controls to maintain stability. In later blocks, such as Block 50 and beyond, an enlarged dorsal spine fairing was added along the fuselage. This accommodates additional fuel or equipment, enhancing range and avionics capacity without significantly altering the core aerodynamics. The F-16 Fighting Falcon became the first production fighter to receive a fly-by-wire flight control system. This technology was introduced on the F-16A model in the late 1970s to make the aircraft less stable in flight, but much more maneuverable. For reliability, this system had 4 independent channels. It automatically controlled the aircraft's flight surfaces, preventing stalls, although the pilot could always override the system. In later versions of the aircraft, the flight controls were made digital for greater precision and better integration with modern electronics. Replacing traditional mechanical linkages with electronic signals became the key to the incredible agility of the fighter. This feature has remained the foundation of all its variants since its first flight in 1974. The cockpit is equipped with a system that allows the pilot to control weapons, radar, and flight without taking their hands off the throttle and stick. This innovation, first applied specifically on the F-16A, significantly reduced the workload on the pilot during aerial combat. It works together with the head-up display, where all essential information is shown. Thanks to further upgrades, the aircraft learned to automatically receive target data from ground forces and display video from targeting pods. The multifunction displays have evolved from early black and white screens to modern color panels. For example, the Block 60 version received 3 large screens with their own processor, while the newest Block 70 models feature a high-resolution center display. It shows color maps, the aerial situation, and digital flight instruments. Helmet-mounted cueing systems also help monitor the situation in the air. They began to be widely installed in 2004 and were first used during Operation Iraqi Freedom to aim weapons without needing to turn the aircraft itself toward the target. In 2020, an even more advanced helmet was tested on the latest F-16V fighters. It projects information directly onto the visor and allows the pilot to maintain excellent situational awareness in combat, both day and night. For defense, the aircraft has radar warning receivers that detect threats in a timely manner. In addition, the fighter can carry electronic warfare pods to jam enemy radars and protect itself in the air. Thanks to continuous upgrades, the F-16 cockpit remains modern and ready for any mission in the 21st century. The fighter has 9 hardpoints for mounting weapons, 1 on each wingtip, 3 under each wing, and 1 more under the fuselage. This allows it to carry a maximum payload of 17,000 pounds. Such an arsenal makes it possible to combine different types of weapons. For example, AIM-9 Sidewinder missiles for close combat, AIM-120 AMRAAM missiles for hitting targets beyond visual range, and precision JDAM smart bombs for strikes on ground targets. Complementing its external stores, the F-16 is armed with an internal M61A1 Vulcan 20mm rotary cannon mounted in the left wing root, which has a capacity of 511 rounds of ammunition for close-range engagements. For enhanced targeting capabilities, particularly in night and all-weather conditions, the aircraft integrates systems like the Lantern pods, which provide forward-looking infrared imaging and laser designation to support precision-guided weapon delivery. The F-16 avionics suite, including fire control radar and cockpit displays, facilitates accurate weapon aiming and integration across these systems. In United States service, the F-16 maintains compatibility with nuclear weapons, notably the B-61 gravity bomb, which can be carried on designated hardpoints for tactical nuclear delivery roles. Beginning with Block 50 and later variants, the F-16 has evolved to incorporate advanced munitions, such as the Joint Standoff Weapon and the AGM-84 Harpoon anti-ship missile, expanding its multi-role capabilities while maintaining seamless integration with existing hardpoints and targeting systems. The F-16 Fighting Falcon was initially equipped with the Pratt & Whitney F-100-PW-200 afterburning turbofan engine, which provided 23,830 pounds of thrust with afterburner for early production models. This engine featured a dry thrust of approximately 14,670 pounds and was selected for its balance of performance and reliability in single-engine applications, though it faced early challenges with durability that prompted subsequent improvements. Starting with Block 30 aircraft, the General Electric F110-GE-100 became available as an alternative engine, delivering 28,200 pounds of thrust in afterburner while offering enhanced reliability and reduced maintenance requirements compared to the contemporary F100 variants. The F110 series incorporated advanced materials and design features, including a more efficient afterburner system that supported high-thrust operations. In testing, some configurations even enabled limited supercruise attempts by reducing fuel consumption during sustained supersonic flight without full afterburner engagement. Specific fuel consumption for the F110-GE-100 was improved over earlier engines, contributing to better overall efficiency. For later blocks, such as Block 50, the F100 was upgraded to the F100-PW-229 variant, which increased thrust to 29,100 pounds with afterburner through enhancements like a higher pressure compressor and improved turbine durability. This upgrade also extended the engine depot maintenance interval to 6,000 total accumulated cycles, a significant advancement facilitated by modular design elements that allowed for easier component replacement and life extension programs. Similarly, the F110-GE-129 variant, used in advanced F-16 configurations, provided 29,000 pounds of thrust class performance with comparable afterburner capabilities and further reliability gains, including longer on-wing times between overhauls. These engine variants share a common airframe mounting interface, requiring minimal adaptations for interchangeability across F-16 blocks. Overall, the progression from the F-100PW-200 to more powerful and efficient options like the F-100PW-229 and F-110-GE-129 has enhanced the F-16's operational flexibility and sustained its relevance through modular upgrade paths. The F-16 Fighting Falcon achieved full combat readiness for the United States Air Force on October 25, 1980. This followed the initial delivery of these aircraft to the 388th Tactical Fighter Wing at Hill Air Force Base in January 1979. As the very first operational unit to receive the F-16, they spent 1979 conducting extensive testing of the aircraft. They ran training sorties that clearly demonstrated the jet's agility and showcased its new fly-by-wire systems in realistic scenarios. Early on, the focus was on advanced training exercises like Red Flag at Nellis Air Force Base. There, pilots practiced both air-to-air and air-to-ground combat alongside other Air Force aircraft, preparing for real-world combat through large-scale simulated engagements. When Operation Desert Storm commenced in 1991, the Air Force deployed 249 F-16s. Collectively, they flew over 13,000 missions against Iraqi targets, representing the highest number of sorties flown by any aircraft type within the coalition. Many of these missions involved high-risk runs to suppress enemy air defenses. F-16s fired AGM-88 HARM missiles to neutralize Iraqi surface-to-air missile sites and radar installations. This action cleared the way for other strike packages and played a crucial role in achieving air superiority. Whether engaging enemy aircraft or providing close air support for ground troops, the F-16 proved its versatility throughout the 42-day campaign. Following Desert Storm, Air Force F-16s were instrumental in enforcing no-fly zones over Iraq during operations such as Southern Watch. They subsequently returned to intense combat roles during the invasions of Afghanistan in 2001 and Iraq in 2003. In these conflicts, F-16s executed thousands of missions, providing close air support, conducting precision strikes, and gathering intelligence. The jets readily adapted to the evolving warfare tactics, utilizing upgraded targeting pods and smart munitions right up until American forces began their withdrawal in the 2010s. By the mid-2010s, as combat operations in Iraq and Afghanistan wound down, the F-16 fleet redirected its focus toward homeland defense, training, and global deterrence. As of 2024, the Air Force maintains an active fleet of approximately 800 F-16s, distributed across active duty, Air National Guard, and reserve units. However, the military is progressively transitioning to the newer F-35 Lightning II to acquire fifth-generation stealth capabilities. To support this transition, retired F-16s have been repurposed as Q-F-16 aerial target drones. The final delivery of 127 of these drones concluded in 2025. Currently, they are employed in live fire exercises and adversary training, serving as realistic threats for pilots and modern weapon systems to practice against. Over in the Middle East, the Israeli Air Force received its very first F-16 Fighting Falcons in July 1980. The first 4 jets, known locally as the Nets, or Hawk, touched down at Ramat David Air Base. This made Israel one of the earliest international operators of the F-16, and they lost no time putting the multi-role jet to work. By the end of 1981, 75 F-16s had been delivered, quickly becoming the backbone of Israeli air power. A major turning point occurred on June 7, 1981, during Operation Opera. 8 F-16A fighters bombed and destroyed the Iraqi Osirak nuclear reactor near Baghdad. Flying with F-15 escorts, the F-16s traveled approximately 683 nautical miles in complete radio silence. They dropped their precision bombs perfectly, with each jet striking exactly 5 seconds after the one before it. They wiped out the target without losing a single aircraft. This high-stakes mission proved beyond a doubt that the F-16 possessed incredible long-range strike capability and unmatched agility. In 1982, during the Bekaa Valley campaign as part of Operation Peace for Galilee, Israeli F-16 jets played a central role in achieving air superiority over Syrian forces. Alongside F-15 jets, F-16 jets provided interception and defense, while F-4 Phantoms conducted primary attacks. This contributed to the destruction of all 19 Syrian surface-to-air missile batteries in the valley within 2 hours, utilizing real-time intelligence and electronic warfare. In subsequent air battles, Israeli fighters, including F-16 jets, shot down 82 Syrian aircraft, primarily MiG-21 and MiG-23 jets, with no Israeli losses in air-to-air combat during the operation. In the 2010s, Turkish Air Force F-16 jets conducted operations in Syria, striking Daesh targets including command posts, weapons dumps, and ammunition depots in northern Syria. These missions, reported as early as June 2018, involved multiple F-16 sorties that destroyed several high-value targets. This supported ground operations against terrorist groups, with no specific loss details disclosed. Israel has continued to modernize its F-16 fleet with variants like the F-16I Sufa, introduced in 2004. It features conformal fuel tanks for extended range and locally developed avionics such as helmet-mounted displays. In January 2025, Elbit Systems was awarded an $80 million contract by the Ministry of Defense of Israel to upgrade the F-16I fleet with an advanced self-protection suite. This includes radar warning receivers, missile approach warning systems, and directional infrared countermeasures to enhance survivability against modern threats. The F-16 Fighting Falcon was co-produced in Europe through agreements involving NATO allies such as Belgium, Denmark, the Netherlands, and Norway. They participated in manufacturing the first 650 United States Air Force units, 348 European aircraft, and shares of exports to other nations. These countries established production lines, including one in the Netherlands at the Fokker facility, to assemble their own fleets. Under the initial program, Belgium acquired 116 aircraft, Denmark 58, the Netherlands 102, and Norway 72. Total acquisitions eventually grew much higher, with Belgium operating 160, Denmark 82, and the Netherlands 213. This co-production enhanced NATO interoperability and local industrial capabilities, with the aircraft entering service in these air forces during the late 1970s and 1980s. During NATO missions in the 1990s, F-16 jets from Belgium, Denmark, and the Netherlands played key roles in Balkan operations, including enforcing no-fly zones and conducting airstrikes. The Royal Netherlands Air Force deployed 18 F-16A fighters to the region at the height of operations. They contributed to campaigns like Operation Deliberate Force in 1995, where NATO flew 3,515 total sorties to degrade Bosnian Serb forces. Similarly, Danish and Belgian F-16 jets undertook hundreds of sorties supporting peacekeeping and enforcement efforts across the Balkans, bolstering NATO air superiority. During the 2011 NATO intervention in Libya under Operation Unified Protector, F-16 jets from Belgium, Denmark, and the Netherlands conducted strike and support missions. They contributed to the coalition's total of 26,500 sorties over 8 months, including approximately 7,000 bombing runs against Gaddafi regime targets. These nations, operating similar F-16 variants in mixed squadrons, flew dynamic targeting missions alongside allies like Norway, demonstrating the multi-role versatility of the aircraft in enforcing United Nations resolutions. In Asia, the Republic of Korea Air Force uses F-16s for air defense patrols along the Korean demilitarized zone. They maintain readiness against North Korean threats through routine intercepts and surveillance missions from bases like Osan. These operations highlight the F-16's role in regional deterrence, with recent upgrades improving sensor fusion and weapons for sustained border vigilance. Over in Taiwan, the Air Force has integrated F-16s into its operations amid tensions in the Taiwan Strait, conducting patrols and readiness exercises to counter potential invasions. Back in the 2010s, Taiwan upgraded its F-16A and B fleet with advanced engines for better payload and range, and added anti-ship missiles like the AGM-84 Harpoon. These enhancements, part of the broader F-16V modernization, will keep the aircraft effective in anti-invasion roles through at least the mid-2020s. In 2024, European nations including Denmark and the Netherlands donated F-16s to Ukraine as part of Western aid against the Russian invasion. The first aircraft arrived in early August 2024 to boost Kyiv's air defenses, achieving their first confirmed combat successes that same month by downing Russian cruise missiles. Denmark pledged 19 F-16s, while the Netherlands committed more units, marking a major transfer of European air power to support Ukraine. Turkey has heavily relied on its F-16 fleet during the Syrian civil war throughout the 2010s. In July 2015, 3 F-16s from Diyarbakir Air Base dropped smart bombs on militant positions in northern Syria. These jets have also provided air cover for ground troops. As recently as 2020, Turkish F-16 Vipers flew alongside drones and artillery to deter Syrian government forces. Even earlier, in 2012, Turkey frequently scrambled F-16s along the border to counter Syrian helicopter incursions, proving the aircraft's value in border defense and escalation control. Egypt sent its F-16s to strike Libya in February 2015. They targeted training camps and weapon stockpiles near Derna, retaliating for the group's execution of Egyptian Christians. While these multiple sorties successfully hit militant positions, they also drew criticism due to reports of at least 7 civilian casualties. Meanwhile, in Venezuela, the country's F-16 fleet showed its potential readiness during joint exercises with Su-30s in 2025. This projected deterrent power amid regional tensions, although severe maintenance issues mean only about 5 of their 24 aircraft are actually airworthy. Looking at export trends after the year 2000, the F-16 continues to spread globally. As of 2024, over 25 nations operate the jet, proving the ongoing demand for its multi-role capabilities. Iraq, for example, started buying F-16s in 2008 to rebuild its combat aviation after the invasion, ordering 36 jets. Morocco followed with a major purchase that same year and later expanded its order in 2019 to include 25 new Block 72 variants, along with upgrades to its existing fleet to secure regional air superiority. In the 2020s, the main focus on the export market was drawn to the modern Block 70 variant. In 2018, Slovakia purchased 14 of these jets to update its air defenses and support NATO missions. All aircraft are expected to be delivered by the end of 2025. Bulgaria followed a similar path, ordering its first batch of 8 F-16 Block 70 fighters. Their production is also scheduled to finish in 2025, and later the country plans to buy more jets. The process of mastering the F-16s transferred to Ukraine in 2024 has faced serious challenges. These include delays in pilot training, which could take anywhere from 4 to 5 years, the need to tune electronic warfare systems to counter Russian threats, as well as complex logistical issues with maintenance and training. The first production versions of the Fighting Falcon were the F-16A and B models. They covered the series from Block 1 to Block 15. The A version was a single-seat jet, while the B was a 2-seat model meant for training. These early aircraft were built primarily as light daytime air superiority fighters. They featured an innovative fly-by-wire flight control system, a teardrop canopy for perfect visibility, and a Pratt & Whitney engine that put out 23,830 pounds of thrust on afterburner. The first production series, Block 1, consisted of 94 jets. Deliveries began in 1979. They had a basic radar and small horizontal stabilizers. That same year, these aircraft entered active duty with the 38th Tactical Fighter Wing at Hill Air Force Base in Utah. Each subsequent series brought new improvements. Block 5, which consisted of 197 jets, got a gray radome for better camouflage and internal upgrades. Block 10, which numbered 312 aircraft, featured upgraded electronics. The most numerous early version was Block 15. Over 14 years, several factories produced 983 of these jets. They received 2 extra hardpoints under the fuselage, a reinforced structure to handle more weight, and tail stabilizers increased in size by 30%. This significantly improved handling at high angles of attack. Thanks to these changes, the jet could carry an additional 1,000 pounds of weapons and use AIM-7 Sparrow missiles. In total, over 1,400 fighters of these series were built, becoming the backbone of American and Allied air forces well into the 1980s. The real breakthrough came with the series from Block 25 through Block 42, known as the F-16C and D. In 1984, they evolved into true multi-role aircraft, capable of operating in all weather conditions. These models received a new, longer-range radar featuring 25 operating modes for precision strikes and beyond visual range air combat. The cockpit introduced multifunction displays, a wider head-up display, and upgraded computers. The radar warning receiver antennas were moved to the leading edge of the wing for better coverage. The airframe was strengthened again, and the maximum takeoff weight increased to 42,300 pounds, allowing them to carry more fuel and weapons. Equipped with new Pratt & Whitney engines, these fighters were ready for the most complex missions, including night attacks and electronic warfare. Key differences within these blocks included engine options, starting with Block 30, which introduced the General Electric F110-GE-100 turbofan option. Blocks 30 and 32 combined produced 733 aircraft. Block 30 used the GE engine, featuring a modular inlet for optimized low-speed performance and about 5,000 pounds more thrust than the F-100. Meanwhile, Block 32 variants retained compatibility with the Pratt & Whitney engine. Block 25 production totaled 244 units exclusively for the United States Air Force, focusing on AMRAAM missile integration and doubled chaff and flare dispensers. Blocks 40 and 42, produced from 1988 onward, added Lantern targeting pods for night and all-weather operations, digital flight controls, and stronger landing gear. At least several hundred units were built, including exports to Egypt and Bahrain. In total, over 1,700 F-16C and D aircraft were manufactured in Blocks 25 through 42, transitioning the F-16 toward more advanced configurations in later decades. The Block 50 and Block 52 variants of the F-16 Fighting Falcon, introduced in the early 1990s, represented significant advancements in multi-role capabilities. They incorporated improved performance engines, enhanced radar systems, and specialized targeting equipment to support both air-to-air and suppression of enemy air defenses missions. These blocks featured the AN/PG-68 version 5 radar, with enhanced signal processing and additional modes for better reliability and target detection. They also included common embedded GPS and inertial navigation systems for precise navigation and all-weather strike operations. The Block 50 utilized the General Electric F110-GE-129 engine, while the Block 52 employed the Pratt & Whitney F100-PW-229. Both provided increased thrust and efficiency over earlier variants, enabling an internal fuel capacity of approximately 7,000 pounds for extended range without external tanks. Additionally, integration of the HARM targeting system allowed these aircraft to perform wild weasel rolls, targeting enemy radar emissions with AGM-88 HARM missiles. This was a capability that replaced aging F-4G aircraft in United States service. Over 800 Block 50 and 52 aircraft have been produced, starting from 1991. Deliveries to the United States Air Force began that same year, and exports commenced shortly after to allies seeking advanced fighter capabilities. Notable exports included 48 Block 52 plus aircraft to Poland in the early 2000s, equipped with precision GPS for enhanced all-weather strike precision. Around the same time, 50 Block 52 plus jets were sent to Greece, bolstering NATO's southeastern flank with improved suppression of enemy air defenses and multi-role performance. These variants emphasized modularity, allowing for future upgrades like the Common Configuration Implementation Program, which added advanced cockpit displays and weapons compatibility without major structural changes. The F-16E and F-Block 60, developed exclusively for the United Arab Emirates Air Force, further advanced the platform with desert-optimized features and superior avionics. This marked a custom variant produced under a $3 billion program funded entirely by the UAE. First flown in December 2003, it incorporated enlarged square air intakes to handle sand ingestion in arid environments, conformal fuel tanks for increased range without drag penalties, and integration of the Sniper Advanced Targeting Pod for precision targeting in ground attack roles. Powered by the General Electric F110-GE-132 engine, producing 32,500 pounds of thrust, the Block 60 also featured advanced precision GPS systems. These enabled all-weather GPS-guided strikes with munitions like the Joint Direct Attack munition. A total of 80 units were produced. This included 55 single-seat F-16E models and 25 two-seat F-16F models. Deliveries started in 2005 and were completed by 2010, making it one of the most capable export variants at the time. The F-16V, also known as the Viper, represents a significant modernization of the F-16 platform. Unveiled in 2012 as an upgrade package, it features advanced avionics and sensors. Central to this variant is the integration of the Northrop Grumman AN/APG-83 Scalable Agile Beam Radar. This is an active electronically scanned array radar, often referred to as AESA, that provides enhanced all-weather targeting, high-resolution synthetic aperture radar mapping, and interleaved air-to-air and air-to-ground modes. Additionally, the F-16V incorporates the Automatic Ground Collision Avoidance System, or AGCAS. This system automatically intervenes to prevent controlled flight into terrain, greatly improving pilot safety during low-altitude operations. This upgrade builds upon the capabilities of earlier advanced models like the Block 50 and 52, focusing on enhanced situational awareness and mission versatility without requiring a full airframe replacement. Adoption of the F-16V has been prominent among international operators, particularly in response to evolving regional security needs. Taiwan initiated its F-16V upgrade program in 2012 with a major contract, equipping its fleet with the APG-83 radar and subsequent additions like AGCAS to bolster its air defense capabilities. Similarly, Greece has pursued a comprehensive upgrade of 84 F-16C and D aircraft to the Viper configuration. Deliveries are progressing steadily and are expected to reach the halfway mark by late 2025, incorporating the AESA radar for improved combat effectiveness. However, the standard F-16V upgrade package is constrained by the original structural design of the airframe. This limits compatibility with conformal fuel tanks that could otherwise extend its operational range. In contrast, the Block 70 variant introduces brand new F-16V aircraft with structural enhancements. These upgrades enable the integration of conformal fuel tanks for substantially increased fuel capacity and mission endurance. These tanks, mounted along the fuselage without compromising aerodynamics, provide a notable boost to range. This allows for longer patrols and reduces reliance on external drop tanks. Production of Block 70 aircraft takes place at the Lockheed Martin facility in Greenville, South Carolina, which supports foreign military sales and is ramped up to meet global demand. Key contracts include Slovakia's 2018 order for 14 Block 70 jets. Deliveries commenced in 2023, with full production completion expected by late 2025. Bahrain also secured a $1.1 billion deal in 2018 for 16 Block 70 aircraft. This made Bahrain the first customer for this variant, with initial deliveries starting in 2023. By 2020, upgrade kits for the F-16V configuration had been sold to multiple nations, facilitating widespread adoption of these modern features. As of 2024, the F-16 Fighting Falcon remains in active service with numerous air forces worldwide. The estimated total active global fleet exceeds 2,000 aircraft across more than 25 countries. The United States Air Force operates the largest fleet, primarily for air superiority and multi-role missions, while export operators utilize the aircraft for similar versatile roles, including ground attack and reconnaissance. Production and upgrades continue, ensuring the aircraft remains relevant in modern militaries. Major current military operators include the following, with fleet sizes reflecting data primarily from 2023 and 2024 estimates. Exact figures can vary due to ongoing upgrades and retirements. The United States operates a total force of 862 aircraft. As of 2023, this included 726 F-16Cs and 136 F-16Ds, with the fleet expected to adjust to approximately 838 aircraft after 2024 retirements. These jets are used for air superiority, training, and multi-role operations, and are flown by active duty, the Air National Guard, and the Air Force Reserve. Turkey operates between 243 and 260 F-16s. As one of the largest non-United States fleets, Turkey utilizes the aircraft as a multi-role fighter for both air defense and ground attack missions. Israel operates between 197 and 224 aircraft, with over 100 upgraded to advanced standards. These are used for air superiority and precision strikes, and are extensively used in regional operations with ongoing modernization. Egypt has between 27 and 218 multi-role aircraft for air defense and ground support, maintaining a significant fleet with recent acquisitions. South Korea flies between 161 and 167 jets for air superiority and reconnaissance, with the fleet undergoing upgrades for enhanced capabilities. Taiwan has 136 in service, with a total of approximately 200, including 66 on order. They provide air defense against regional threats, featuring recent upgrades to the F-16V standard. The United Arab Emirates operates 80 Block 60 variants for advanced multi-role operations, with a strong emphasis on precision strikes. These jets are equipped with specialized Desert Falcon upgrades. Other notable current operators include Greece, with 153 aircraft for NATO air policing, as well as Bahrain, Jordan, Poland, and Ukraine, where they were recently introduced for defensive roles, contributing to the overall active inventory. These fleets highlight the enduring versatility of the F-16, with many nations integrating variants like the Block 50 and 52 or the F-16V for sustained operational effectiveness. The United States Navy operated a fleet of 26 F-16N and TF-16N variants as adversary training aircraft for its fighter weapons school. However, they retired them in 1994 due to structural issues, including wing spar cracks and metal fatigue. These aircraft, which were modified from standard F-16A and B models with the internal cannon removed to reduce weight, were the only non-Air Force United States military F-16s, and they marked an early phase-out from naval service. In Europe, several nations have retired their F-16 fleets amid transitions to more advanced platforms like the F-35. The Royal Netherlands Air Force decommissioned its F-16s on September 27, 2024, after 45 years of service that included multiple combat deployments. They subsequently donated 24 aircraft to Ukraine as part of a Western coalition effort to bolster its air defenses. Similarly, the Royal Danish Air Force accelerated its F-16 retirement timeline, announcing in June 2023 a phase-out by the end of 2025. This is 2 years earlier than originally planned, a move made to facilitate the introduction of F-35A fighters, with formal retirement ceremonies scheduled for January 2026. Other examples include the Vermont Air National Guard, which retired its F-16s in 2019 to make way for F-35 integration. These retirements, often driven by the need to replace aging airframes with stealth-capable aircraft like the F-35, have seen hundreds of F-16s phased out globally since the early 2010s, though exact totals vary by nation and variant. The Philippines has emerged as a key potential operator of the F-16, with the United States government approving a major arms sale in April 2025. This package includes 16 F-16 C Block 70 and 72 single-seat fighters, along with 4 F-16 D Block 70 and 72 twin-seat trainers, valued at approximately $5.58 billion. The goal is to bolster the Philippine Air Force's maritime domain awareness and air defense capabilities. This deal, which includes advanced avionics, munitions, and training support, marks a significant step in modernizing the aging fleet of the archipelago nation amid regional tensions. Vietnam has also shown growing interest in acquiring F-16 fighters during the 2020s, driven by the need to upgrade its Soviet-era aircraft amid escalating geopolitical challenges in the South China Sea. Reports indicate potential negotiations for up to 24 F-16V Block 70 variants. This is the most advanced configuration available, featuring upgraded radar and mission systems, though no final agreement has been confirmed as of 2026. This prospective acquisition reflects the strategic diversification of Vietnam regarding defense suppliers beyond traditional Russian platforms. In civilian applications, the F-16 has been adapted for adversary training roles by private contractors to support military exercises. Top Aces, a leading provider of advanced airborne training, began operating F-16A and B aircraft in 2021 under a United States Air Force contract, delivering realistic red air simulations for the United States Air Force, United States Navy, and other Department of Defense entities. The company has expanded its fleet and capabilities, including integration of synthetic training elements on its F-16 aggressors to enhance live fly scenarios, addressing the demand for cost-effective threat replication. The F-16 Fighting Falcon has experienced numerous accidents and incidents since entering service in 1978, with aviation safety records indicating approximately 748 losses due to crashes as of 2024, primarily from training, operational, and combat scenarios. These losses include both non-combat mishaps and combat-related events, often attributed to factors such as pilot error, mechanical failures, bird strikes, and enemy action. Investigations into these incidents have frequently led to safety enhancements in aircraft design and operational procedures. One notable United States training accident occurred on March 31, 1985, when an F-16 crashed shortly after takeoff from Fort Campbell, Kentucky, killing the pilot, Captain Ed Johnson. The aircraft, assigned to the United States Air Force, struck the ground in a wooded area during a routine training flight. The cause, determined after an official investigation, was pilot error. Another significant United States mishap in August 1985 involved an F-16A that crashed on the Utah Test and Training Range during a training mission. The aircraft was written off, and the pilot was killed. The incident was initially linked to a control system malfunction under investigation by Air Force officials, and later determined to be controlled flight into terrain. In 2003, a mid-air collision between two United States Air Force F-16C Fighting Falcons occurred on October 25th, approximately 82 miles southwest of Hill Air Force Base, Utah. Air Force investigators attributed the incident to pilot error. One pilot was killed, while the other ejected safely. The incident highlighted the risks involved in formation flying during training exercises, leading to procedural reviews. Combat losses have also marked the history of the F-16. The United States Air Force recorded 5 F-16 lost in combat during the 1991 Gulf War due to enemy fire. For example, one F-16 from the 388th Tactical Fighter Wing crashed after being hit by Iraqi anti-aircraft fire, resulting in the pilot's death. Investigations confirmed these losses contributed to tactical adjustments in subsequent missions. In a more recent combat incident on February 10, 2018, an Israeli F-16 Isufa was shot down by Syrian air defenses during a strike on Iranian positions in Syria. This marked the first loss of an Israeli F-16 in over 3 decades. The two pilots ejected and were rescued. An Israeli military probe cited a professional error in navigation and threat assessment as a contributing factor. This prompted a broader retaliatory operation that destroyed significant portions of the Syrian air defense network. Specific causes in various F-16 incidents have included bird strikes, as seen in multiple United States Air Force mishaps where ingestion led to engine failure and crashes. Friendly fire has also been a factor in other contexts. These events, investigated through joint military boards, have informed upgrades like improved radar warning systems to enhance survivability. Overall, while losses remain a part of the operational history of the platform, modern upgrades have contributed to safety improvements in the fleet. The F-16 Fighting Falcon has left a significant mark on popular culture. Movies and video games often highlight its maneuverability and versatility. In the 1986 movie Iron Eagle, this aircraft is at the center of the plot. The story follows a young pilot who steals an F-16 for a risky rescue mission, thrilling audiences with breathtaking aerial stunts. Although what was shown on screen was somewhat exaggerated, it cemented the F-16 as a symbol of modern combat aviation. People began to view it as the undisputed leader in aerial combat. This fighter is also prominently featured in the Ace Combat video game series. There, the F-16C and F-16F models serve as versatile aircraft for complex missions. Players appreciate them for their speed and lightning-fast strike tactics. These games have only reinforced the reputation of the jet as highly maneuverable, making it an integral part of aviation-themed entertainment that draws on real combat experience. Beyond media, the legacy of the F-16 lives on in museums and exhibits around the world, where these jets serve as prime examples of aviation innovation. The National Museum of the United States Air Force houses an early version of the F-16A in its Cold War gallery. It was previously flown by the Thunderbirds demonstration squadron and now showcases the aircraft's journey from a prototype to an advanced multi-role fighter. Another F-16A is on display at the Israeli Air Force Museum at Hatzerim Air Base. It is a true veteran with several aerial combat victories. It was preserved as a mark of respect for its role in defending Israel, perfectly illustrating the global impact of this aircraft. Such exhibits serve as a reminder not only of the technical achievements of the jet, but also of its influence in shaping aerial tactics after the Vietnam War. An important part of the F-16's history is its unofficial nickname, Viper. Pilots named it this because of its sleek and predatory design, which resembled a fighter from the 1978 television series Battlestar Galactica. This name caught on even better than the official Fighting Falcon. It perfectly highlights the speed, maneuverability, and lethality of the fighter. The nickname Viper quickly spread among aviation enthusiasts and the military, firmly securing the F-16's status as an icon of fourth-generation fighters that revolutionized combat aviation. The F-16 Fighting Falcon was designed as a single-seat multi-role fighter. However, there are also two-seat versions, for example the F-16B and F-16D. These are designed for a two-person crew for training and special missions. This design helps the aircraft perform its primary roles of achieving air superiority and attacking ground targets. The single-seat models are focused entirely on operation by a single pilot. The length of the F-16 is 49 feet 5 inches. The wingspan is 32 feet 8 inches, and the height is 16 feet. Thanks to these compact dimensions, it remains incredibly maneuverable and less visible to radar. The empty weight of the aircraft is 19,700 pounds, and the maximum takeoff weight reaches 37,500 pounds. This allows it to carry a substantial combat payload for a wide variety of missions. The fuel supply is key to its endurance. The internal tanks hold about 7,000 pounds of fuel. For long-distance flights, additional drop tanks can be attached, each holding up to 600 gallons. The maximum operating altitude exceeds 50,000 feet, providing excellent performance at high altitudes. And the airframe is designed to withstand up to 9 Gs during sharp maneuvers. Newer modifications like the Block 70 have improved specifications. For example, their maximum takeoff weight is increased to 48,000 pounds, which significantly expands the combat capabilities of the jet. The F-16 Fighting Falcon is an incredibly powerful fighter, perfectly suited for high-speed interception, extended missions, and complex aerial maneuvers. Its maximum speed reaches Mach 2.05, or about 1,350 miles per hour at an altitude of 40,000 feet. This allows it to instantly respond to threats and maintain air superiority. This speed is provided by a single, high-thrust turbofan engine. Thanks to this, the aircraft can climb to an altitude of over 50,000 feet. With extra fuel tanks, the F-16 can cover a distance of 2,280 nautical miles without refueling, which is ideal for long-distance deployment. In combat conditions, the combat radius is 340 nautical miles. In this configuration, the aircraft carries 4 bombs weighing 2,000 pounds each, 2 AIM-9 missiles, and external tanks with 340 gallons of fuel. Of course, this figure depends on the payload and mission type. According to official United States Air Force data, even with only internal fuel, the flight range exceeds 2,000 miles. The fighter's high maneuverability comes from a thrust-to-weight ratio that exceeds 1. With the Pratt & Whitney F-100 engine, this figure typically sits between 1.1 and 1.3. This gives the aircraft excellent acceleration and climb rate with an empty weight of 19,700 pounds. Because of this, the F-16 can pull a sustained turn at 20 degrees per second, allowing it to conserve energy during prolonged dogfights. Equipped with drop tanks, The fighter can patrol an area for roughly 4 hours, flying reconnaissance or supporting ground troops. On variants like the Block 50 or Block 52, you can mount conformal fuel tanks, which extend that flight range even further. Its primary built-in weapon is a 20mm 6-barrel M61A1 Vulcan cannon loaded with 511 rounds. It has a rate of fire of up to 6,000 rounds per minute, making it incredibly lethal in close combat and during ground attack runs. When it comes to missiles and bombs, the aircraft features 11 hardpoints, 2 on the wingtips, 6 under the wings, and 3 under the fuselage. In total, the F-16 can carry up to 17,000 pounds of weapons and equipment. In an air combat configuration, it can carry up to 6 short-range AIM-9 Sidewinder missiles with infrared guidance and up to 6 AIM-120 AMRAAM missiles, which strike targets beyond visual range using radar. For ground strikes, the fighter can be armed with 6 AGM-65 Maverick missiles using either television or infrared guidance, an ideal weapon against armored vehicles. The bomb arsenal is just as impressive. The F-16 can load up to 12 conventional 500-pound Mark 82 bombs or 4 precision GBU-39 small diameter bombs, which minimize collateral damage during urban combat. Any weapon configuration can be combined with extra drop tanks, targeting pods, and electronic warfare systems, turning the aircraft into a truly versatile fighter in the air.